Chào các bạn đến buổi coding với anh Hoàng. Thì không để mất thời gian nữa thì anh Hoàng từ Google sẽ móc cho bạn ly. Hoàng lo nốt nhé. Sau móc theo đúng format của Amazon hay gì đó, hay Google gì đó.
Okay.
Ok, tôi để nốt cho ông nhé. Ok.
À, ok. Em có thể zoom lên một chút, zoom cái doc lên một chút.
Ok.
525 rồi đấy. Ok, vậy. Mùa 4 giờ 11 đúng không? Là đến 5 giờ. 50 phút cho là 50 phút đi. Ok. Rồi nha.
Ok, vô luôn ạ.
Okay, hello Lee. My name is Quang, and today I will be your interviewer. We can start with a simple problem. Yeah, let's skip the introduction part. So the problem will be so you are given an m time and binary grid. It's just a map, and it's only
Right.
contain 0 and 1. Zero mean uh zero mean like an empty cell, okay, and 1 mean a wall, okay,
All right.
and you are at uh top left cell, okay.
Okay.
We want to go to bottom right, and you cannot go to a wall. You only can go to the empty cells.
Mm-hmm.
And you at each step you can go like 4 direction, like up, down, left, right. And
Right.
let's see. Yeah, and the question is very simple, like find the minimum number of steps that you need to walk to go from top left to bottom right. Yep. Step number. Right.
Okay. Well, just one small clarification. I think you mean the destination to be like m-1 and n-1, right?
Yeah, right.
Yeah. Well,
My bad.
my first thought seeing this problem, I think this is a pretty standard
Hmm.
algorithm problem that we all learn in school.
Okay.
And to do this, we can use the BFS algorithm. And to start, the BFS algorithm will be init with the first cell at 0, 0,
Hmm.
and we will stop when we get to the destination. Yeah.
Okay.
Then, yeah, do you want me to elaborate more on the algorithm, or we can talk about the complexity?
Uh, yeah. Okay. Tell me more about the runtime.
Sure. So the for BFS, the runtime will be, let me write it down. The time will be in the total number of cells, which is m multiplied by n. And space, since we use a queue, we may have to store all of the cells inside the queue. Uh, I mean, yeah, we just consider the worst case, so it will be all the cells too, so it will be m and n also, because the queue is a problem, and then we have to store the distance for every single cell, so it will be m and n in space too.
Okay. Uh, sound very simple and straightforward. Okay, I will add a follow-up here, maybe make it harder.
Sure.
So let's assume that so currently you cannot go to war, right? But
Right.
let's say you have some tool, like bomb or something, you can like eliminate it to war. Let's say you have uh, like bombs, and you can use form to eliminate overall. Okay.
I see.
So same question, like find the minimum step. You can go, given that you have k bomb.
Well, the first thing come up in mind is that we can still use BFS, but we will alternate things a bit. So previously, in the original problem, we have m plus n cells, right? That will equal to like m plus n state in the BFS. So in the original problem, the BFS only needs to iterate through at most m plus n states in order to get the distance. But for now, I think we can increase the state a bit. It means that when the BFS reach a cell, right, it also wants to know how many bomb that it has used. Yeah, so let me write it down. M plus n, so that will be m plus n plus k states. And the way that we're gonna transition from a state to another is, let's say we at 0, 0. We are at 0, 0. Okay. And let's say 0, 1 is a bomb. So we have two options. The first option is that we no, actually we only have one option if we want to go to this cell, right? We have to use the bomb, the tool, right? And when can we use the tool? When we still have the when we haven't used all of them yet, right? So initially we have k used in total. And if we were to use, then we can have this kind of transition.
Okay.
Yeah, something like that. Yeah. And the distance will apparently be okay. I think what I'm writing, okay, something like this. Yeah. So I think I'm gonna model the problem to be something like this. And yeah, for every time we use the bomb, we will decrease k until k is 0. And if k is 0, apparently we cannot go to this cell anymore because we cannot use the tool anymore. Yeah.
What about the case where you don't need to use the tool? Like it's not a war. How do you?
Well,
Yeah. What is
if
it?
it's not a bomb, then if it's not a bomb, then we can just do like normal. That would be, we will not decrease k like this. Yeah. I think we can use a if else clause for this. Yeah. Do you want me to discuss the complexity?
Yeah. Go ahead. Yeah.
Okay, so for the time, because this is BFS and we have this much state, so that would be O of this. Same for the space also.
Okay. So good. Okay. So what about if I want to know the path that you take? Not only this number of steps, but like the actual
The actual path, right? I think okay, this is gonna be a little bit tricky. I think my idea now is that we will still keep doing BFS like before, and then at the end we can use the distance matrix to trace back the steps. Yeah. I think, can I visualize this with the first original problem?
Sure.
Yeah, because I think the essence of the problem are like the same in the two problems. So let me write a table down. Okay, let's say we have let's say this. Okay, so this is the distance matrix. So
Okay.
at 0, 0, it is 0. Let's say this is a wall. This is apparently distance of 1. This is of 2. Let's say this is a wall 2. This is 2. This is 3, 4, and 4, right? And our destination is over here.
Okay.
So I think what I'm gonna do is that the way I'm gonna trace is that I'm gonna trace from the destination. And I'm gonna see that it is number 4. I will look around the 4 adjacent cells, and I see this one is number 3. It means that from this cell I can reach to the destination, right? So I will go to number 3, and when I go to number 3, I'm gonna look around through. I'm gonna look around again. This is the left cells is number 4, so I'm gonna ignore it. But then I can see this cell is number 2, so I'm gonna go here. And of course, I have pushed all of these cells, 4, 3, and 2. I have pushed them, let's say, into a vector or something, into an array, right?
What if you have two options, like more than one option? Like,
I think if I have too many options, then I can just choose whichever, because from whichever option I can still, like, let's say this is 1, right? So from this number 2, apparently I can choose the top cell or the left cell, but my argument is that choosing whichever is fine, because like you can still reach that cell in one step, and or this cell in one step. It doesn't really matter.
yeah.
Yeah, so let's say I choose this one. And then I can see that my top cell is the start and it has the number 0. So I choose it too.
Okay.
Mhm.
So good. Yeah, I think you can. I think the idea makes sense to me. I think you can start implementing the solution.
Sure.
Yeah, let's start with the number of step only first. Yeah.
So I will implement the first problem with the path, right? I will return the path of the first problem.
The second one.
Mm,
Move on.
Okay. Well, let me think a bit. So first off, I will need a BFS. And then I will need the I need let's see, the disk matrix, and then the Q for BFS, and then yeah, that will be enough. So is it okay if I use like global variables? Like it's just similar for this problem, I think, although it's not good practice.
Yeah, we can improve later. But you can go with that first.
Okay. So I'm gonna use maybe C++ for this.
Okay.
Now, thing I need is the Q. Now this Q, it has to save the cells. Let's say it's a pair in actually, yeah. BFS. This will be the BFS queue, and then I will need the distance matrix. Okay. Let's say we have M and N first, right? And and now we're gonna init it with this. Initially, all of them will be 0.
1 second. So are you implementing the first problem or second problem?
I'm implementing the first approach. I mean the first problem, the one without the bombs.
I think we can, start with the bomb as well.
Okay.
The same, right?
Yeah. I thought you were talking about. Okay. Actually, is it better if I use Python? Maybe Python would be easier to implement.
Yeah, whatever that. Up to you.
Or can I like can I tweak the syntax of C++ a bit, because I'm not very confident in Python, and I can write in C++, but it's gonna be like a lot of syntax, and I want to keep it simple for now.
1 second, let me see. Let us assume that you have something like this.
Oh, okay. I think we can use that. I think for this one, I can just maybe do another vector. Okay, I'm just gonna simplify it.
Yeah,
Let's just say this, right? These are the dimension, and this is the value. I think the value should be infinity. Yeah, just say that's infinity. And let's say infinity now is let's just say like this. Although I'm not sure this will be the infinity, because it kind of depends on the dimension of the matrix.
should be fine.
Okay. Now, now let's start with the problem. Now let's say the original graph that we have is a 2D matrix that is a Boolean, where true is, let's just say in, where 0 is empty and 1 is the wall. Yeah, just not gonna init it. And then we can go to the BFS. This BFS will simply fill in the values for this distance matrix. Okay. We know that the first one is 0, 0, and the distance is also 0.
Okay.
Also init the dist. Oh, actually it's k. I need another k here too. No. Okay, now that I have the current state, I want to iterate through the next states, which are the 4 adjacent cells. I just have this auxiliary array for the steps. Let's see. We need to check if the next coordinate is actually the valid one. They may be out of bound. X is the rows. And if it's out of bound, we can just continue. Okay. Now the next bomb will be, let's just say curve bomb. But if the next cell is a wall, then the next bomb has to be decreased because we need to use a bomb.
Yeah.
No, yeah. Uh, yeah. And then we need to have another check. If next bomb is less than 0, then apparently we have to skip this cell also.
Okay.
Yeah. And after all these checks are done, if we still pass, then it means that we can process this next cell. We also need to check if the distance is the minimum one possible, because otherwise we will have duplicate cells in the BFS queue. Like this. Maybe let's just say, candidate dist is the distance from cur to this cell and here. Yeah, like this. And if the current dist of next is, well, let's say if it's larger or equal than candidate dist, then we just gonna continue also. Right? Because apparently we have already visited the next cell and we have already pushed it into the queue, so we don't have to push it again. And in the case that it hasn't been visited yet, then we're gonna assign it with this candidate dist, and then we're gonna push it into the queue.
Is this plus one here? Like,
Oh, yeah, yes. Sorry. My bad. And actually, I missed one here too. This taxi, mhm. Okay. this at the very beginning. All the steps. Illegal. If this is wrong, then this is okay. Looks pretty good to me. Right, and I think we can stop early by doing this. If corrects is equal to, actually we can stop at another place, can we? I'll just stop here. If corrects is equal to m minus 1 and y is equal to n minus 1, it means that we have already reached the destination. If we have already reached, then we can just stop immediately and we don't have to continue the BFS. This is kind of a minor optimization. Now, after all this is done, we have already filled our dist matrix. And so I think this function can end here. Right. And this is how we're gonna find the distance to our destination. The only job left is to find a path, right? And let's say finding path is another function. Let's say trace path. Actually, yeah. And this trace path is gonna use the value in the distance matrix to find a path. Let's see, how am I gonna code this out? Current cell is equal to, now this is, there is a tricky part in this because our distance has 3 states and one of them is redundant in our trace path function, which is the next, which is the bomb dimension. When we trace path, we don't need to care. Actually, we still need to care. Actually, we need to care. Yeah, so I think what I want to say is that when we want to trace the path, then our destination R is m minus 1, n minus 1, and let's say question mark, because this can be any value ranging from 0 to k, right?
Yes.
Let's just say 0 to k. Then I think that we can make this simpler by passing the destination cell into this function, and then we can iterate through all of our states, all of our destination state later when we use this function. Something like,
How do you find this first?
can you repeat your question?
Like, how about we find the third dimension first? So you don't need to iterate one by one. Because we only care about the short hit, right?
Yes. Yes, that is correct. Huh. Yeah. Yeah, you have a point. We don't need to go through all of those states. We just need to go to the one with the small shortest path. And if there are multiple cells with shortest path, then we can just pick either of them. That is nice. Okay, so the first thing I'm gonna do is I'm gonna find the k. I'm gonna find the value for the third dimension that has the shortest path.
Yeah.
How do I do this? And then okay. And list of -1 and -1 I is less than this of can I just write it like this for now?
Okay, yeah, fine.
Yeah, I think there will be more clarity if I write it like that. Now, if this is larger than or equal, then we'll skip this one. Otherwise, we're gonna update the current cell to be -1 and -1 and I, something like that. Yeah.
Okay.
Now we're gonna start the trace. Now that we already have the destination, we will trace until we reach the start destination. So that would be while I think it's good. Yeah. While current cell is not the start, it's not at the start yet, which is this. Now we also need a vector to store the path. Just say this is gonna be I assume that when we trace the path, we don't need to know how many bomb we used, right?
No.
It will be the in only.
Mm.
Oh, right. Okay. Initially, it's gonna have the mm, okay. I'm gonna use something like this instead of like first and second for clarity. I hope
Is
this.
it
I
is
hope
it
it's okay.
on an n minus one?
Yeah. Can you repeat that? Yeah.
Isn't it n minus one or on an n minus one?
This is m-1, and this is n-1. Actually, just call it row and column.
Okay.
Yeah. And now we're gonna trace back. I will need this array. We're gonna trace back these steps. And I'm gonna also need this too. Okay. I think my naming can be improved, really, because I have X and Y, and also row and column. For now, let's just keep it like that, and I can improve later.
Yeah.
For X, for Y. Okay, so if the path is already now, this is the next cell in our trace. We need to find the bomb too. So let's say in next bomb is current cell bombs, and if the next cell is a wall, then wait, no, if the current cell is a wall, actually. This means that if the current cell is a wall, then it means that the previous cell must have used a bomb in order to reach our current cell, right? I think let's just rename this to something like previous cell for clarity. This is the previous cell, and if the current cell is a wall, then the previous cell, they must have used a bomb. It means that previous bomb has to be like this. Like this. Yeah.
Okay.
Now, okay. After this is done, after this is done, we will have to check if this previous state is actually the state that can go to the current state. It means that, for example, if we are at number 2 here, that it means that the previous state, it must have the distance of 2 minus 1 equals to 1. Yeah, and we need to check that. And that will be the last condition that we need to check. If distance of this if this plus 1 is not equal to Curtis, then we will also continue. We skip this. And if after all our checks are done, then we can add this cell into our path. Now our path is constructed like in reverse order, so we will have to reverse them later on. And then we can update the current cell too, to be something like, yeah. And so we will keep doing this loop. No, actually, if we have found it, we have to break also.
Right.
Right. So it will just keep going through this while loop. Eventually, we will go back to, because here the previous dist is always lower than the current dist. Eventually, we will go to this number 0, which is our initial cell. And yeah, that's basically how we know that we are definitely gonna reach the initial cell, because the disk will keep decreasing until 0. And so after we reach the initial cell, we will have finished. And so we can return the list. Actually, we need to reverse it first, and I'm not sure how to reverse it in C++. I think there's something like, I think so.
Yeah, that's right.
Okay, and so then I can return it.
I think, yeah, we have an escape where there's no path. Like no matter how many bombs we use, we cannot reach the destination. That can happen, right?
Yes, that is true.
Can you
If
have
let's see, in that case, it means that our destination cell will have the distance of infinity, and we will exhaust this loop without ever breaking at all.
Yeah.
And this will go on forever and ever. I think we can put a check right here before we even start the trace. We will use a symbol condition to check whether it is equal to infinity, because infinity means that we haven't reached that cell yet, right? So it means something like this. This of current cell is equal to infinity. We don't have a path. And if we don't have a path, then we can just return an empty list.
Okay.
Yeah. Okay. And after this, I will have, let's say, a main function to call these two functions. Now let's just assume that we have filled in the inputs. The inputs are the global ones.
Okay.
Now we're gonna call BFS, and then after it, we can go straight to calling the trace path. The auto path equal to trace path. Yeah. Then we can print out.
Okay, yeah. I think it should. Let me see. Let me check it.
Yeah, it's been pretty long. I think
Uh,
this will be.
yeah, definitely it will not compile, but it's okay, I think.
Yes.
Okay. Can you scroll down a bit? Like, I think
Do you want to?
it should be current bomb, is it?
Uh,
Scroll down, scroll down a bit in the trace function. It's fine.
oh, for
It,
this. Yes. That was my mistake. It should be current bombs. Let's just init one here also. Like this.
right, I think this look good to me. Yeah, we're running out of time. I will send the feedback to Facebook later. Okay.
Mhm. Okay. Yeah. Thank you for spending time interviewing me. Yeah. I think my code was pretty it is not like cleaned up. I hope you can understand it.
Yeah, it's okay. Like we're coding in Codec anyway. Not a standard IDE. Okay, thank you for your time. I think we can end here. Ok, có gì anh sẽ gửi feedback vào message nhé.
Dạ, ok. Ok. Cảm ơn anh nha.